In this video, I'm going to show you how to find the distance between 2 points and find the midpoint of a segment. So when you're given a graph, the easiest way to find the length of the segment, or the distance between the points, is to simply use the Pythagorean theorem. So if I were to make a right triangle out of this, where the segment is the hypotenuse, it might look like this. It doesn't matter if I draw the triangle above or below. But just sort of counting the squares, I see that this side has length 4, and this side has length 6. All right, so the segment is the hypotenuse, so a squared plus b squared equals c squared. Basically, I'm calling this c right now. So that would be 4 squared plus 6 squared is equal to c squared. So that's going to be 16 plus 36 is equal to c squared. So that's going to be 52 is equal to c squared. And then, of course, we take the square root and that's going to give me the length of the segment, which I've called c. So the exact length is radical 52, and that's going to be approximately something, whoa, too big. Anyway, let's see, square root of 52. So that's approximately 7.2, how many decimals did they say? 1 decimal place. So that's 7.2. So approximately 7.2. So this is the answer. Next, we're supposed to find the midpoint. Sometimes you can use the graph to find the midpoint as well. Notice the rise and run that we did to draw this triangle. It's up 4 and right 6. Well, if you're going to find the midpoint, then you're going to do half of that. So instead of going up 4, what if we went up 2? And instead of going right 6, what if we only went right 3? That should give us the midpoint. Okay, so it's just a matter of taking half. So instead of up 4 and over 6, we went up 2 and over 3. And we now see that the midpoint is -1, 0. Okay, now if that had been a decimal or something, this probably wouldn't have worked out so well. So maybe I should go ahead and mention the midpoint formula. So the coordinates of the leftmost point here are -4, -2. And the coordinates of the point on the right are 2, 2. So we could have used the midpoint formula to find this. And the midpoint formula is just the average of the x's and then the average of the y's. In other words, x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So imagine that we did that. So then we would have the average of the x's. So it would be -4 plus 2 divided by 2, and it would be -2 plus 2 divided by 2. All right, it's just the average of the x's and the average of the y's. So then what would happen? -4 plus 2 is -2, so that'd be -2 over 2. -2 plus 2 is 0, so that'd be 0 over 2. And then you can see -2 over 2, that's 1. -1. And 0 over 2, that's 0. So we would get the same answer. And sometimes you have to use the midpoint formula if the midpoint falls between the lines in a weird way. Like if the midpoint came out to be approximately 7.2, probably we couldn't have found it just by using the graph. But when you can find it using the graph, that's usually the quickest way. Moving on to number 2. Find the length of the segment by finding the distance between the endpoints. Round to 1 decimal place. Again, if they give me the graph, the easiest thing to do is just to use the Pythagorean theorem. So I'm gonna do that again. So again, I'm going to kind of draw my triangle by drawing the rise and run. And the length of the vertical side of the triangle, let's see, that's 4 and 3, so this is 7. And the length of the horizontal part of the triangle is 4. And again, I will call this C. So that sets me up to do the Pythagorean theorem again. So C squared is equal to A squared plus B squared. So C squared is equal to 7 squared plus 4 squared. C squared is equal to 49 plus 16. So C squared is equal to 65. So that means that C is equal to the square root of 65. Square root of 65 is approximately 8.1. All right, got a round. So this is the answer to problem number 2. Now, the midpoint. Let's see if I can use my same trick as before. This still might work. Half of 7 is 3.5. So instead of going down 7, I could go down 3.5. So that would be like this. All right, so I'm right here. And instead of going right 4, I'm going to go right 2. So if I went to the right by 2, okay, 1, 2. So that's going to put me right here. Okay, so that puts me at the point 3, comma, 0.5. Okay, because I went down 3.5, I went down 3.5. That left me half of a square above the x-axis. All right, and I can see that I'm landing on 3 as I go to the right 2. Anyway, so I found the midpoint. So the midpoint is 3, comma, 0.5. It was a little bit weird because of the decimal, so maybe we should go ahead and do the midpoint formula just to verify. Okay, so we could have done the midpoint formula, which is right here at the top of the screen, the average of the x's and then the average of the y's. I guess I need to write down the coordinates. So this first point is 1, comma, 4, and the second point is 5, comma, negative 3. So I could have done the average of the x's, so that's 1 plus 5 over 2, and then the average of the y's, so that's 4 plus negative 3 divided by 2. So that would have given me 6 over 2 and 1 over 2. I started to put a negative, but that's not right. Try again, Burton. So that's going to be 1 over 2. Okay, which of course is just 3 and 1/2, or 3, comma, 0.5, which is what we had in the first place. So now I've shown you 2 different ways to get the answer. All right, for number 3, they did not give me a graph. So I might want to use the distance formula, which I haven't showed you yet. But first, let me show you that you could make your own little graph. Okay, so I'm just going to draw a right triangle. So this is going to represent the vertical change between these 2 points. Okay, and this will represent the horizontal change between these 2 points. and then this will be the distance between those 2 points. Okay, so basically bam and bam, that's the distance. Okay, it doesn't matter if this triangle is not really rotated the right way. The distance will still work. So if I want to find the vertical change between these 2 points, I should be looking at the y values. And I should be asking myself, how far apart are these? How far apart are 15 and -3? Well, picture it on a number line. Okay, so here's 15 and here's -3. All right, somewhere between them is 0. How far apart are these? All right, if you can see at a glance that these are 18 units apart, then this method is for you. All right, if you're looking at this and you're not seeing where I'm getting 18 from, then probably you want to use the distance formula, which I'm going to show you in a second. Okay, now what about the horizontal change? All right, which I'm showing here in green. Of course, the horizontal change is going to be how far apart are the x values. That's the horizontal change. All right, you probably don't need a number line for this. Here's 2 and here's 10. How far apart are these? These are 8 apart. If that's not obvious to you, you probably do not want to use this method. But if it is, this method is probably the best method for you, because you can quickly draw a nice little diagram which will accurately reflect the distance between these 2 points. Okay, so now again, I'm going to call this C, and I can go ahead and do a squared plus b squared equals c squared. Okay, so c squared is going to equal to 18 squared plus 8 squared. So that means that c is going to equal, okay, 18 squared is 324 plus 8 squared. Well, okay, I'm not sure why I typed that into a calculator, but 8 squared is 64. And if we add these together, that's going to be 388. This is still c squared. So that means that c will equal the square root of 388. So let's find out what c is approximately. 1 decimal place. Okay, so the square root of 388. Okay, apparently that simplifies to 2 root 97. Fine, but let's get that decimal. Boom. 19.7. Approximately 19.7. So this is the answer for problem number 3. Now, real quick, before we get to the midpoint part, let's go ahead and let me show you the distance formula. So another way I could do this is, look, the distance between 2 points is the square root of x minus x. So I could say x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula. And I'm hoping you'll see why this is the same as what we just did. Okay, so this is going to be, now watch what happens. I'm going to do x minus x. Okay, so I'm going to do 10 minus 2. So I've got 10 minus 2 squared. And then I'm going to do y minus y. So that's going to be 15 minus -3. All right, be careful. It's not 15 minus 3. It's 15 minus -3 squared. But watch what happens right now. What is 10 minus 2? That's 8. All right, can you see that that's just the 8 that we got right here? So this part of the formula, the x2 minus x1, that's just the horizontal change. That's just the distance between the x values. So we really did this. We really did the same thing. We just did it in steps. Okay, and then this 15 minus negative 3, you have to know that minus and negative is addition. And of course, that's going to give you 18. And again, oh look, 18. That's the vertical change that we found, the distance between the y's. Okay, so it's really the exact same thing that we had in the first place. And of course, we had to take when we did it before, we had to take the square root at the end to get the hypotenuse. And here we have the square root. It's the same thing. All right, so obviously after this, it's just going to become what we already did. So you can use the formula if you're more comfortable with that, or you can draw yourself a little diagram if that's easier for you. For the midpoint, I'm definitely going to use the midpoint formula. I am going to think of this as the average of the x's, comma, the average of the y's. All right, because that's an easy way to remember the midpoint formula. So the average of the x's, of course, I'm going to add them up and divide by 2. So that's going to be 10 plus 2 divided by 2. The average of the y's, that's going to be 15 plus negative 3 divided by 2. So what happens? This is going to be 12 divided by 2. And 15 plus negative 3, that's just 15 minus 3, really. So that's also going to be 12 divided by 2. So that's going to give me 6, 6. So that would be the midpoint of these two ordered pairs, the midpoint of the segment. Okay, for number 4, we have 2 new points. We're supposed to find the length of the segment. If we did the distance formula, here's how it would go. And I'm going to show you one additional thing here. We could just do x minus x. So this would be negative 4 minus negative 9. Just be real careful. It's not negative 4 minus 9. It's negative 4 minus negative 9. And then I have to do y minus y. So that's negative 1 minus 11 squared. One additional thing I wanted to show you is if you have the use of a scientific calculator like the TI-30XS Multiview, you might want to consider just typing the entire expression into your calculator at once. So I'm going to demonstrate that this time. So negative 4 minus negative 9. All right. Notice I had to use the 2 different types of minus sign. All right, the black one and then the white one for the negative 9. Also, the negative 4 had to be the white one. Anyway, that's the downside of using the calculator, is having to be careful with those things. Anyway, plus, all right, here comes negative 1. So I'm going to put this kind of a minus sign. And then minus 11. And don't forget the square. All right, so if you type it in very carefully, you can just put the whole thing in your calculator and get the answer all at once. So there's nothing wrong with that if you're comfortable with it. So there's your distance formula. So just one more time though, if I wanted to do this by sketching a little diagram, I'm going to show that to you now. So I'm going to sketch a little diagram, guys. So here's a vertical change, and here's a horizontal change, and then this would be the distance in between the 2 points. Okay, so let's start with the horizontal change. What's the distance between negative 4 and negative 9? Whenever I see negative signs involved, it might help to put it on a number line. So here's negative 9, and here's negative 4. The question is, how far apart are these? All right, I'm hoping you can see that these are 5 apart. Okay, they're both on the negative side. You know what I mean? Like 0 is like over here somewhere. These are just 5 away from each other. So the horizontal change is 5. Okay, now what's the vertical change? Okay, so for the vertical change, now I'm looking at the y values, boom and boom. And again, I think I'll just put this on a number line real quick. All right, here's -1, here's 11, all right, here's 0, just for reference. How far apart are these? 12, all right, because this is 1 to the left, 11 to the right, that's a total of 12. So the vertical change is 12. Okay, so if you're comfortable with that, then this method is probably easier for you. And then we'll just do the Pythagorean theorem. So if I call this c squared is going to equal to 5 squared plus 12 squared. Okay, I'm going to show you one more little trick here. That means c is going to equal the square root of 5 squared plus 12 squared. If you didn't feel like showing the steps in between, again, for this problem, I'm going to show you how to use your calculator a little bit more. We could just do the square root of 5 squared plus 12 squared. All right, that just saves us the steps of having to do the 25 and then the 144 and then add those together and then take the square root. If we've got the calculator, why not use it? Okay, so we get c is equal to 13. All right, this is my preferred method. Anyway, now let's find the midpoint. We know that the midpoint is simply going to be the average of the x's, comma, the average of the y's. So that's what we're doing. So the average of the x's, so that's going to be -4 plus -9 divided by 2. And then the average of the y's, so that's -1 plus 11 divided by 2. So what's that? -4 plus -9, that's -13 divided by 2. And then -1 plus 11, that's going to be 10 divided by 2. Okay, if I didn't want decimals, then I would have to leave this as -13 over 2, comma 5. If decimals are okay, then this is going to be -6.5, comma 5. Okay, so either one of these would be an acceptable answer. All right, number 5 is an interesting problem, a little multiple choice problem. They don't actually want us to sit here and calculate using the distance formula and all that. They just want us to use our common sense and say which of these makes sense as possible answers. For example, a midpoint is a point, right? It's an ordered pair. So there's only one ordered pair up here. So out of these options, we would know it would have to be the 4, 7.5, okay, without even calculating. If these are our only answers, it couldn't be either one of these other ones. Okay, now, that leaves the length and the slope. Well, we know when we do the length, we very often, the distance formula has that square root right in there. And even if we're doing the Pythagorean theorem with c squared is equal to a squared plus b squared, ultimately to get c by itself, we wind up taking the square root of both sides. So it makes sense that the square root is going to be part of this length, okay, if these are the options. Okay, so square root of 53. On the other hand, we know that slope is rise over run, so it makes sense that that would be a fraction. So there's your 7 over 2. All right, so that was a fun little quick problem. Now, moving on to number 6. Write an equation of the circle that has a diameter with these endpoints. Okay? Well, remember what a diameter is. So I'm going to draw a quick diagram. So I see 12 comma 11 and I'm sorry, negative 12 comma 11, 2 comma 11. So look, I'm not going to formally put this on a really nice graph. I'm just going to do a rough sketch. Okay, so here's my circle, and there's the center, and here comes a diameter. Okay, so I could have these points on the end. So let's say this is our negative 12 comma 11 point, and this is our this is negative 12 comma 11 and 2 comma negative 11. Okay, just to make it somewhat reasonable, I feel like I should draw it at a diagonal. All right, so here's my circle. All right, and I've got this diameter happening. So here's my negative 12 comma 11 point, and here is my 2 comma negative 11 point. All right, we need the equation of this circle. So for the equation of the circle, the main thing we need is the center. The center is just going to be the midpoint of this segment. So the first thing we need to do is find the midpoint, which is the center. The midpoint is the center. Okay, so that's going to be the average of the x's, comma, the average of the y's. So in other words, that's going to be negative 12 plus 2, okay, divided by 2, and 11 plus negative 11 divided by 2. So that's going to be negative 10 over 2 and 0 over 2. So this midpoint, the center, is going to be negative 5 comma 0, because that's what you get from this. So now we have the center. Right away, just based on the center, we can write the left side of the equation. It's going to be x plus 5 squared, because it's going to be opposite of that, and then plus y squared. Since it's a 0, there won't be any addition or subtraction happening. Now, all I need now is the radius, so that I can do the radius squared. Okay, so I know that the coordinates of the center are negative 5 comma 0. So if I want the radius, I can just find, I can now find the distance between these 2 points, and that'll be the radius. Or I could find the distance between the original 2 points and then take half of that. Which one should I do? It doesn't really matter. I think I'm going to go back to the original points. So that way, if this were a test, I could get partial credit for getting the radius right, even if I got the center wrong. So that's just a good strategy. So now I'm going to find the radius. Well, I'm going to start by finding the diameter, and then that's going to give me the radius. All right, because the radius will be half of the diameter. Okay, so I'm going to find this whole thing. I'm finding the diameter. So I'm going to use my little method of drawing a triangle and doing the Pythagorean theorem. All right, so this is my diameter right here, my little schematic. But what's the horizontal change? Well, the horizontal change is going to be the distance between the x values. So what's the distance between negative 12 and 2? All right, understanding that 0 would be right here. Hopefully you can see that that is going to be 14. All right, these are 14 apart. So horizontal change, 14. What is the vertical change going to be? the vertical change, that's just going to be the difference in the y values. Okay, what's that going to be? Well, let's look at that on a number line. So one of the values is negative 11, and the other one is positive 11. All right, 0 is right here. How far apart are these? Well, that's 22. All right, it's 11 to the right, 11 to the left, total of 22. So the vertical change is 22. Okay, so now I'm just doing the distance formula. Okay, so I could call this diameter c. So I will know that c squared is equal to a squared plus b squared. All right, so which means that c is going to equal the square root of 22 squared plus 14 squared. All right, so this is going to be the diameter and I'm just going to put that whole thing in the calculator. Square root of 22 squared plus 14 squared. Okay, I'm going to go ahead and get decimals. Boom. So 26.077. That's the diameter. The diameter is the whole way. So the radius will be half of that. So now I'm going to take that and I'm going to divide by 2. And then that should be the radius. So this is 13. Well, I'm rounding to the 1 decimal place. That's what the nearest tenth means. So that really comes down to 13.0. All right, because it's 13.03, so 13.0. All right, so that's the radius. So the radius squared is going to be about 169. All right, I'm just doing 13 squared. So there is the equation. All right, I mean, we're done. But again, I could have used the distance formula if I wanted to find the distance between these, to find the diameter. I could have gone the square root of, and then it goes x minus x squared. So that would have been negative 12 minus 2 squared plus y minus y squared. So that would be 11 minus negative 11 squared. I could have done that, and then I could have put that whole thing in my calculator. So that would have been the square root of negative 12 minus 2 squared plus 11 minus negative 11 squared. All right, so of course we're getting the exact same thing that we got the other way. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.